So, hello everyone. Welcome to this complete DBT Cloud session. So, I'm Madhu, your professional data engineering trainer. So, today we will covering everything from DBT basics to production ready CI/CD pipelines, all in the 40 minutes. So, let's go start. So, here, go to second slide. So DBT stands for DBT stands for data build tool. It is a open source framework. Okay, it is a open source framework that lets data analysts and engineers write SQL transformation inside the data warehouse. So here DBT stands for data build tool. It is an open source framework that lets data analysts and engineers write SQL transformations inside the data warehouse. So in our case, Snowflake, you write SQL, DBT compiles and runs it. Okay, we going to write SQL code. DBT going to compile those code and it going to run that code. So that's it. Okay, here no need for no Python, no complex pipelines, just SQL plus some Jinja templating we're going to use. Okay, here no Python, no complex pipelines, just SQL plus from Jinja templating. DBT handles everything. So else dependencies, as testing, documentation, lineage, these things. Okay, so here we see we have the time. Okay. So we have ELT versus ETL. Okay. So ETL means like extra transform load. Okay. So this is transform before loading the data in ETL. Okay. ETL means extra transform load. Like before loading. Okay. We are doing the transform. So here you can see transform before loading. Okay, then ELT. So this is extract, load, and transform. Okay, so transform inside warehouse. It means so DBT when we are loading data from S3 to Snowflake. Okay, after that we are doing the transformations. After loading data S3 to Snowflake, then we are connected with the DBT. So then we are using the. So here, okay, after transforming inside, okay, after loading the data into the warehouse, not only the Snowflake warehouse, we have a Redshift, BigQuery, some other data warehouses. After loading data into the warehouse, when we have data in the warehouse, then we need to connect with the DBT, then we need to do the transforms, this thing. Okay, so then DBT is the T. Okay, here we have yield, right? DBT is the T in the ELT. It's going to do the transformations. So it does only transformations. Okay, basically it does only transformations. Okay, here raw data analysis. Okay. So your raw data stays in the Snowflake. There is like a bronze layer. So source tables we're going to have. Then raw data Snowflake in the bronze layer. Okay. First, we will load data S3 to Snowflake, right? So those data, those layers we can call like bronze layer. So bronze layer that inside that we're going to have the raw data. So after, okay, so after what we do after when we have data in the these in the bronze layer, so next what we going to do here. Okay, here see, so in ETL, so extra data transfer to outside the warehouse. Okay, extra transform load outside the warehouse. Then load it in DBT follows ELT. So when we are connected with the DBT, when we have data in the warehouse, then we are connected to DBT, right? Then it's going to follow the ELT. Extract load first, then transform inside Snowflake. So DBT literally the T in the ELT. So it reads from your branch raw tables, then transforms and writes results back to silver or gold tables. DBT does not move the data, it only transform. Okay, so DBT not going to move the data, just DBT going to transform the data. So when you transform the data, that results back to silver or gold tables, okay, in the DBT, sorry, in the Snowflake. Okay, so it reads from your branch raw tables, then transforms and writes results back to silver or gold tables. DBT does not move the data; it only do the transformations. Remember this one. Okay, so next here we will move to next slide. Here we can observe, we can take screenshot. Okay, I will explain now this. So in DBT we have, right, both we have. Okay, we have this one DBT Core, and it is an open source CLI. So run locally on servers. Run locally or on servers. Okay, DBT Core open source CLI run locally or on servers. So DBT Cloud, so browser based IDE, we can schedule the jobs, documentation can generate alerts and APA. Okay, so Cloud IDE, in this we're going to write the SQL codes and running the models. So see lineage in browser. So we can see the lineage graph. Suppose we have one model, so we don't know where it comes from that model. Okay, so what in DBT using lineage graph, so we can check it that graph. Okay, previous model. Suppose think like this is child model. Who is his father? So we're going to see that. Okay, map here, and who is grandfather, we're going to say map here, like that. So we have ABC. Okay, so A, B, C. From this, we're going to create two models. We're going to join A and B, one model, and B and C, one model, two models. Then after joining these two models, we're going to create a C model. Okay. So this is things like child, parent, and grandfather. Okay. So like that, we need to know where this child comes from. Then we need to see the lineage graph. Then from the source, so we are getting, okay. Oh, this comes from so on so product and uh, like orders and payments table, customer table, then we can check it. Okay, so product, orders, customer tables. Okay, here we're going to have some output. Here we're going to have file and summary in this is okay. So DBT Core is the open source CLI version. You install in the your laptop, we're going to install and write SQL, run DBT, run from the terminal. Okay, so DBT Cloud is a managed platform, browser based on IDE, job scheduling environments, host documentation for teams and production use. We use DBT Cloud. So both use same as underlying model logic. The model logic is the same, but you have more features in the. So DBT Core is like free and command line tool. DBT Cloud browser, so managed platform. So with IDE and everything. Okay. So this is about a DBT Core and DBT Cloud. Just move to another slide. Okay, and then okay. So this one, okay. What is the project here? Project folder structure. This is the when you create the DBT account, you're going to have the project folder structure. Okay, here you can see every DBT project has this standard folder structure. Every DBT project going to have this standard folder structure. So models folder has your SQL transformations. So here we're going to do the SQL transformation. So the extension is dot SQL. Okay, for every model we need to give, okay, that product model, product dot SQL, order model, order dot SQL, customer model, customer dot model. Suppose sales summary model, sales underscore summary dot SQL. Okay, so every DBT project has is these standard folder structure. So models folder has your models folder has your SQL transformation files. So seeds has CSV files. Okay, and test, like here we have has custom SQL test, okay, or unique test, not null test, okay, accepted values test, okay, data quality checks, okay, and the relationship test we're going to do here, and this in the test. So macros has reusable Jinja functions. Suppose micro means we have formulas like in mathematics, like a plus b whole square equal to a square plus b square plus 2ab. So in the macros, we're going to write some formula. Uh, I want to find total sum of salary, average of salary, okay, and total amount, and cumulative sum, okay, and total, okay, the customers total paid amount. We're going to write the formulas, okay. We're going to find using macros. It's like work like formulas, okay. So wherever we need it, okay, this macro we will implement in the model, okay. So this macro we will write in the macro folder. We don't execute this one, just we can see the result there, okay. After, when we need it, we will use in the dbt models, okay. So those are macros. So these are reusable ginger functions, okay. Snapshots for se type 2 tracking, okay. And then we have, this is se type 2 tracking. So then the dbt project, this is the main dbt underscore project yml, yaml, someone used to call yaml file. So yml, YAML file. Both are same. Okay. DBT underscore project dot YML is the main config file. It tells about completely DBT, which database, which schema, and metallization to use in the models. Okay. We're going to tell about DBT, which database, which schema, and metallizations to use. Okay. Then go to next slide. Okay. This again. Okay. So here we have, see, this is most very important concept. Okay. This is DBT layers architecture. So bronze, silver, and gold here. Okay. So this is the most important concept. The three layers architecture. So branch layer. Okay. Here, branch layer. So raw data from Snowflake, and here we're going to have the source tables, okay. So we do not touch it, just reference it, and okay, we're not going to touch these, okay. Just raw data from Snowflake, stage models, no transformation, only rename. So light cost means like if anything data type issues, we going to do it. Okay, this is bronze source, so staging. So remember, if they ask about explaining about the project architecture and release, you need to explain everything what I'm here, what I'm telling. This is enough. Okay. Here simply raw data. So stage, just we have only stage models. So no transformations, only renaming and light frosting. Okay. So then go to silver model here. This is, see, bronze sources or staging we need to call, and silver intermediate here, silver intermediate. So these having like staging models. Okay. We clean the data. Okay. We clean the data and rename, cost, deduplication. Okay. Here see, cleaned, deduplicated int models. So for model, we're going to give int underscore model name. So giants as per business logic, filters, business logic starts here, and we will do the testing. Test, okay, unique not an acceptable test. Why we are doing the test means in Snowflake, it not in for the all constants. Even if we given the primary key, still it going to accept the duplicate data. So why means it is a warehouse, right? So it need to handle large volumes of data. So it need to accept the data. That's why it has a duplicate data. So when we have, we can delete using row number duplicate value. That is a very important thing. Okay, and delete. Okay, even we are deleting, we are doing the unique national acceptable test in the snow in the DBT. Okay, so just we are not moving data Snowflake to DBT. Remember, we are not moving the data Snowflake to DBT. Just we are connected with DBT. So everything we going to doing the transfer that going to reflect in the Snowflake warehouse. Okay, Snowflake. So in DBT, suppose you have 1 DB data, one table in the Snowflake. You are creating model on that table. Then same thing like even the 1 DB data. So it not store in this DBT. It will store in the only Snowflake, not store in the DBT, because of it only just connect and it will do the time. Even if you are running the query, The query is going to run in that Snowflake only. Let's check. Create one model, run it, and go check in the Snowflake query history. Then you can find what you have run the DBT in query history. You can check it. You can check it. Okay. So the data not moving to DBT, just even not storage also. Even 1 TB data. So we are not moving to the DBT. Just we do the transformation in the DBT. Then it will reflect in the Snowflake warehouse. Okay. So this is silver layer staging models. We clean, rename, cost, duplicate, and goes to gold. We can call like Mart. Here silver, intermediate, gold, Marts. Okay. So gold, Marts. Here what we do in gold Mart. Gold layer. So here we're going to have the Mart models. Okay. Aggregated business ready tables that feed your dashboards. Every DBT project should follow this pattern only. Okay. So here we're going to have the aggregated data, KVA ready, and fact and dim models. So used by the dashboards, BI dashboard, and see, we going to implement here star schema, fact table having numeric data, fact table going to connect with the dimension table, fact table going to connect with the dimension table. In fact table, we're going to have the only numeric data. In dimension table, we're going to have the description data. Okay, we're going to connect with. So each primary key in the dimension table, those column we're going to have in the fact table. Okay, so here we're going to follow star schema. Okay, aggregated data, completely applying the business rules. Okay, so these data used by the uh, dashboards. Okay, every DBT project should follow this pattern. This pattern. Okay, every DBT project should follow this pattern. So bronze, source, staging, silver, intermediate, gold, marks. Every DBT project should follow this pattern. Okay, so data as it is, clean, business logic. So these are the layers. Okay, then okay. So here we're going to have some environments. So this is always know about environments, layers. Okay. Then only you will get the real time experience. Simply or then you practical doing the test, practical creating models, snapshots, okay, and visualizations, CS suite, doing the test, writing the SQL queries, Jinja templates, okay. You writing the scripts. That's okay, fine, good. That is subject. But we need to know about project, right? So what we need to do in the which layer and which environment, what we need to do. So that we need to know. Okay, what we do related. Okay. So environments for DBT Cloud has three environments. So development, so each developer gets their own schema and underscore username. Okay, then you can do what your task is freely. Okay, and staging or you can call QA or shared environment where CA test. Okay, and runs when you open a pull request and production like this the real deep schedule the jobs live data so PowerShell dashboards never run untested code directly in the production. Okay, here's the reason. So I'm the user Madhu. Okay, so when I go to work on the DBT, so I going to have one schema. That schema name is like so here dev here and underscore my name. Okay, so runs in Cloud IDE. So fast iteration test models. So DBT run, DBT test are commands. We have the models. If you want to run that model, we need to use the DBT run command. And DBT test, it will run the test like unique, not an accept values test. If anything is missing or any error, it's going to show you. It's going to throw the error. So after seeing that error, so we need to modify the data. So this is in the development environment. And go to staging quality. Okay, shade schema. Okay, here also we have stage underscore schema name and scheduled PR triggered. Okay, valid data quality and CAC checks run head everything. So we need to validate the data. Okay, valid data like data quality checking. So CACD continuous integration, continuous deployment going to run here. Okay, so this is a staging or QA we can call. So for testing purpose, Here we develop, here we test, and then we go with the production. Here we have the production schema code underscores, okay, some name, and schedule jobs here using Chrome, okay, and we also have the DBT Cloud scheduler, okay. So using the Chrome schedule and servers like connected with the like VA dashboards, and here also we have the alerts and monitoring here. We need to alert, we need to go with the check the alerts, and if anything is there, we need to monitor these things. Okay? That is in the production environment. This is about development staging production. So normal, here we develop, here we uh, the like testing, here we apply the we go into with the like original data with the client, going to test this in the production. We going to share these with the ways reporting tools, VA dashboards, or VA tab. So these are the environments. Next, we moved some into the subject. So I said the only 40 minutes. I think it will take more time. Okay. I think 3 4 days it will take. Okay. Oh, this one. Okay. So we have a model site in DBT. Okay. We have the models. So DBT models, those are the SQL files. Okay. We need to use the dot file in the extension model. Okay. So we're going to write. We're going to use metallization, and we're going to give. We're going to give. Okay, DB model equal to SQL. These are SQL files, and you're going to use the dot SQL. Okay. Here we're going to use the dot SQL. Okay, suppose model has the some trading. So trading model. Okay, underscore not model name. Okay, sorry, trading. That is a model name. Okay, trading some model name. After that, in the there will be the dot SQL, then it going to run a SQL file. Okay. So this is using this one, we can create a metallization. Using metallization, we can create table or view in the Snowflake. Okay. So then we will be to the will show you something, then you will get one idea. Okay. See, you will get now how to create. See, here we can have staging model. So how to create the model? Okay. So staging models are your branch to silver transformation. So each staging model maps so one to one to source table. We use the source function. So to reference the raw tables, a naming convention stage underscore source name and double underscore table name, and only rename the columns. So cast data types for we're going to use for the data types. So filter nulls, okay, and no business logic here. Keep it. We're going to keep the simple. This in this staging models. How to create a staging model? So this is a syntax. Okay. So I'm running the staging model on the table. Okay. Orders. So this is I'm using the with CTA with source as, okay, and select start from, so source that database name here, the source name is going to here. Okay. Then renamed as select order ID, customer ID, lower as status amount, float out or created order amount, and created a timestamp, created a current timestamp. So this is going to create it and update it timestamp. It is like updated. Okay. These things what after from source, so where ID is not null, select star from rename. Okay, this is one model we're going to create here. We give an extension of the models folder. In the models folder, we are creating a staging folder. So inside we are creating a stage underscore artist dot SQL. So after writing this, we need to run the DBT space run. Just click the enter. It's going to run this model. It's going to create in the Snowflake. Okay, it's going to create in the Snowflake. This is the model. So staging. Okay. So these data for we need to move bronze to silver. Okay. So staging models first transformation layer from source prefix star stage underscore source underscore table example stage underscore snowflake underscore orders. Okay. So this is the naming how we going to give and how we going to give. Okay. So only rename, recast, basic cleaning. So no business logic. Okay. Simply we are renaming the data and recasting the data and basically no business logic. And one to one with source table. So schema that YML defines. Okay. One to one with the source table schema that YML defines source. Okay. So here we need to know right all code with brand and parent and child. So for one to one with source table, schema data define source. So how you get lineage graph? So we need to create one schema data YML file. There we need to write that syntax. Then it will show the lineage graph. Okay. So use source and that schema data YML name and initially we're going to mention one name that is the name is that name and this is the model name. So no reference raw tables source functions though. Okay, source functions raw table references. Okay, yeah, this is how to reference any model means use a source of a name table so to reference the raw tables. I created this stage underscore right dot SQL. Here what I'm going to put here use source of name. Okay, and what I'm given the schema file name and table I put stage underscore data. So to reference raw data. So I need this model in some way. So I will use this syntax, this to take reference this model into the another model. So I use curly braces, source, name and table. So directly if you create like this, it won't work. If you want to refer, first you need to have that in the source table. Then after you can reference the model. First we need to the source and we need to have the lineage graph. And first we need to create in the source table. We need to get one schema data YML file. So database name, schema name in that inside that how many tables are there. We need to create like that. Okay. Then only we will get it. Okay. This is the how to like model. Okay. So models. Okay. In regular class we go into the practical novels. Okay. Next. So intermediate. No, so this we will. So okay, this is completed. Okay. Then are we going to see DBT models? Start this. So DBT models intermediate and Mars and silver gold. Okay. So see. So, intermediate models are silver to silver, complex chains, business logic, calculations. Then, Mart models are the gold layer. So, fact underscore for facts, dim, okay, underscore for dimensions. We're going to use the riff function is DBT is a superpower when you write a riff of stage orders, it automatically resolves the right schema of your environment. Okay, and a dev schema in development of prod schema in the production. So in dev schema, we're going to have the production tables. So, okay. So this one second. Okay. So this is going to create okay what we can do calculation. So Mart models are the goal layer. So fact underscore we're going to use and there is no power. So here, okay, here what we do and fact underscore fact dim underscore dimension. The ref function is DBT superpower. When you write that ref of stage orders, so DBT automatically resolve the right schema for your environment. DBT schema in the development, prod schema in the production. It also builds the dependency graph automatically. Okay, we're going to use the intern graphics here. Okay, you can see this is one model. So model name is we're going to create in the models folder. Inside we have the Mart folders, and inside we're going to create fact orders dot SQL. So here I'm taking a select star from riff of stage orders. So previously we have right stage orders and the silver from the silver. So customer select star from riff of dim customers from the gold and the dim. So again we are writing this code so steps are from fine. So it's going to create it in the Mart layer. So this is we design. Okay, Mart as the requirement. Then this is completely for silver and this thing gold. Okay, here is the so intermediate into prefix giant multiple staging models. So Mart models have going to have fact and fact underscore fact model name and dim underscore dimension name. So use ref of model name to reference the other models. So DBT auto builds the dependence DAG from ref. Okay, calls so gold models. Feed directly to into the BI tools tablet or Power BI. Okay. Gold must feed directly to BI tools tablet or Power BI. Okay. This is think like gold model. So this is the interpret fonts. Okay. Then next is ref function. Okay. So we have right ref. How are we going to use the ref? Right. So here. So ref function is the heart of DBT. So simple. I will give one example. Okay. We write. We go into the bank, we apply for the bank account. Okay. So we will write our first name and last name. Then also we will write our father name, right? So reference, father names, dependencies. We write our father name or mother name. We will mention so son of uh, father name, son of mother name, like that. That is like ref function. Okay, so ref function model dependencies defined DBT. So execution order calculation and ref automatically result to the right schema and in development dev dbt Madhu dot stage underscore we will have and in production we will have the pro db dot and dbt pro dot stage orders we going to okay here we are stage orders in the both okay one in the development in the production both okay, always use riff we are taking the riff we are using the riff here okay always use the riff for models to model so references select star from reference of stage orders this is how to use the model references and never hardcode the table names like select star from table name this is the wrong okay this is the wrong way to do it.
Hi Madhu, sorry to
Yeah.
interrupt. Can you please go a little slow? Little
Oh,
slow.
okay, sure. Okay, so both you want to riff any model, so we need to go with select star from curly braces riff stages. If you want to work with this before, we need to define the schema and environment. Okay, so what you need to do, don't use like select star from fully qualified name. This is the wrong way. We need to go with that. So here what Riff is going to give? So Riff going to give environment aware resolution dev versus cloud. So where we have that model and automatic dependencies in graph that tag. So that's a tag actually graph going to get okay and compile time validation. So fail yearly if model is missing. Then across the database reference support going to check if anything fail. So multiple references in the one model. We can use the multiple references in one model. So orders as Celestia from stage orders and the returns Celestia from reference on stage orders. Customers at the select from the stage orders. Okay, same model we can use uh, so where we need it, not unnecessarily where we need it. So Okay. So tomorrow we will continue. Okay. And some work. Okay. So we completed about up to riff. Okay. So tomorrow we will continue. Okay. Say tomorrow I will take more time, like 1 to 2 hours I will take. Okay. So just some of having the in five some one person have the interview. So go with it. Okay. We will continue tomorrow. We're going to take 2 hours tomorrow. This is only oral, but must attend the regular class. Okay, we will start next Monday with practical and everything. Regular classes, 8 a.m. Okay, so thank you. So anything you can ping me.